Before you go and make your next clothing purchase, you should stop and watch this video. Polyester is everywhere, in our clothes, our carpets, our furniture. But behind this everyday material is an entire world of chemistry, engineering, and increasing environmental concern. Today, we're diving inside the fibers of polyester textiles, what they're made of, why we use them, and what's hiding within. The story of polyester starts in the 1920s, when Hermann Staudinger discovered polymers in natural fibers, a breakthrough that reshaped chemistry. Soon after, Wallace Carothers at DuPont advanced synthetic polymer research, laying the foundation for PET. By 1941, British chemists John Winfield and James Dixon created the first spinnable form of PET. After World War II, DuPont commercialized it as Dacron, and polyester quickly took off. Today, most polyester is made from two petroleum-based ingredients, terephthalic acid and ethylene glycol. They are combined through two main steps, esterification and polycondensation, which build the long PET chain that form the fiber. The molten polymer is then pushed through tiny spinneret holes to make continuous filaments. And as these filaments cool and stretch, the molecules align, giving polyester its strength and durability. But raw polyester isn't enough. Manufacturers add chemical additives at different stages to control color, durability, and performance. During melt processing, titanium dioxide is blended in to reduce gloss and give the fibers a softer appearance. Pigments or dyes are added directly into the polymer melt for permanent color. After the fibers are spun, treatments like flame retardants, softeners, antimicrobials, and water repellent coatings are applied to adjust overall fabric performance.
Did you know that you can be exposed to polyester micro and nanoplastics at every stage in a polyester product's life cycle? The first stage in the polyester product's life cycle is manufacturing, during which polyester fibers are spun in large facilities as shown below. Workers can be exposed to large amounts of polyester fibers in the air as a result of the manufacturing processes. Once the polyester has been formed into its intended products, the consumers can be exposed to micro and nanoplastic fibers that have fragmented off of the products. Fibers can be inhaled from the air or consumed if they fall into water or onto food exposed to the air. As polyester products go through hundreds of washing and drying cycles, they continue to degrade, releasing more and more fibers. Studies have found between 100 and 300 milligrams of fibers can be released per kilogram of fabric that is washed. While most of the fibers are caught in filters or removed in the wastewater, some of the fibers remain attached to the fabrics to be inhaled or consumed like we talked about before. After polyester products have reached the end of their intended life, 12% of them are recycled into recycled polyester products. These products are advertised to be better for the environment, though studies show these products can release 31% more microplastics than new polyester products, making us question how much better they actually are for the environment. The other 88% of polyester products that are not recycled end up being incinerated or sent to the landfill. These extreme temperatures, weather conditions, and shear forces within these facilities create the perfect environment for the formation of micro and nanoplastics. These plastics can be picked up by wind or leach into the groundwater, contaminating the surrounding environments or posing a risk to human health. These pictures depict scanning electron microscope images of polyester fibers. The fibers are extremely small and their fibrous shape lends them to transport easily throughout the environment and into humans. I certainly wouldn't want one of those fibers in my lungs. The dominant method of transport through the environment for polyester fibers is advection. Air and wind can carry these fibers all over, from city to city, even from country to country.
Exposure to microplastic fibers has been linked to respiratory issues and inflammation. Their small size allows them to pass through the biological barriers and reach internal organs, and their rough, irregular surfaces can physically irritate or damage tissues. Microplastics can also carry environmental pollutants, pathogens, and metals. The additives discussed earlier can add to these effects. Groups like PFAS coating and flame retardants are associated with hormonal disruption and other long term health concerns. Colorants, antimicrobials, and other finishing agents may contribute to skin irritation or allergic reactions.
When we talk about risk from polyester micro and nanoplastics, there is still limited research. Lab studies show inflammation and stress responses in cells and in animals, but at real-world exposure levels, the World Health Organization says the overall human risk is probably low, with very high uncertainty due to thousands of potential additives. That uncertainty is a big reason why regulators are starting to act on microplastics as a class of contaminants. In Europe, new rules restrict intentionally added microplastics, and in countries like France, they're going a step further by requiring microfiber filters on new washing machines. Going forward, effective policy will likely combine better product design, filters and treatment technologies, and extended producer responsibility so the burden of microfiber pollution doesn't just fall on the consumers and wastewater treatment plants. Polyester textiles have helped make clothing cheaper, lighter, and more durable, but they've also turned our closets and washing machines into a steady source of micro and nanoplastics to air, water, and soil. The big challenge is now balancing those benefits with smarter design, better filters and treatment, and policies that hold producers, not just consumers and wastewater plants, responsible for microfiber pollution. If we can combine good science, thoughtful regulation, and more sustainable fashion choices, polyester doesn't have to come at such a high environmental cost.